Good morning everyone. Today I am discussing the learning dialogues. Myself, Salve, amrapali from Engineering College of Engineering, Nanded. Now here in the learning dialogues, we discuss the following outlines. The introduction, stack data structure. In that stack data structure, we discuss regarding the definition of stack, the algorithm of push and pop, applications of the stack data structure. And then we move for the queue data structure. Again, we discuss here the definition of queue, algorithm to insert and delete the element from the queues, and the applications of the queue data structures. Now today we will see that the stack is called as a linear data structure in which the insertion and deletion will be performed based on only one end. And here we just perform the algorithms to discuss with the stack data structure. But before that, we just represent the stack is also used the principle as called as the last entered element will be deleted first. It may be shortly we can call as LIFO formats. Now here we discuss the algorithm for push elements into the stack containers. Now we just observe the first step to insert. Check whether the stack is overflow. When the stack will get overflow, to set the top pointer is greater than or equal to n. N is nothing but the maximum length of array. Then we return that the stack is overflow. There is no need to perform the other operations in the algorithm, and then return the 0 values if it is overflow. Otherwise, we can increment the top pointer by 1. Then we set the top is equal to top plus 1. Then we insert the element into the stack container. For that, we require here s of top is equal to elements. Then finally, we return here s of top is equal to the inserted elements, and finally we stop this. Now we can just observe this. There are the the 5 different elements we insert. First element is inserted A, then B, then C, D, and E. While performing the next operation, this algorithm is to insert the element one by one into the queue. That's why this stack is called as a linear data structure. Similarly, we discuss the algorithm to delete the element from the containers. That first we check whether the stack is underflow. The condition for the underflow means there is no elements available in the containers. We set the top pointer is equal to 0. Then we write here the stack is underflow. Otherwise, we return here the 0 values. In the step number 2, we can delete element, but whenever we want to delete the element, we require the position of stack container. That element is equal to s of top. That element will be deleted. After deleting that element, then we can decrease the pointer by 1. That top is equal to top plus 1. Then we return s of top is equal to s of top minus 1. Then finally we stop here. Now we just see the applications of a stack data structure. Basically, the stack data structures can be used for the convergence of expressions, evaluations of expressions, parenthesis matching, recursion, tower of Hanoi, and sweet box routing. Now we can see the reflection spot we observe in this in the first basis questions. My question is to convert the following expressions into the postfix format as well as the prefix formats. The expression is in the first parenthesis bracket, I am using here a plus b divided by c minus of d. Then we just observe to get the answer that convert that expression in the postfix format means the operators are always followed with the operands. Now see the resultant value of this one is ab plus and cd minus divided by. Then we think that how we can convert this expression in the form of prefix format. Now we can see that the answer which is reflected with the postfix along with the same for the prefix expression. That prefix expression means what? The operators must be followed with the operands. Now the convergence of this expression is in the form of this one is prefix, that is division, plus AB minus of CD. This is a convergence of infix format to this prefix formats. This is my reflection spot 1 I created. Now I can use the queue data structure. In the queue data structure is a linear data structure in which the insertion can be performed from one end and deletions can be performed from other end. And now we can see that the algorithm to insert the element into the queue data structure. First we checked whether the queue is overflow, then reset the rear end set point is equal to size minus of 1. Then right here queue is overflow, then return the 0 value. Step 2, Increment the rear pointer by 1. Set rear is equals to rear plus of 1. Then go for insert the element. Set q is equals to rear is equals to elements. Q of rear is equals to elements. Then reset. Return here q of rear. Reset the front pointers. If set front pointer is equals to 1, then else, otherwise front pointer will get increased with one more pointer. Then stop there. We just observe we can insert the element from this end and we try to delete from other ends. And for insertion purpose we can use here the rear pointer, and for the deletion purpose we may be use here the front pointers. Now we can go for this algorithm to delete the elements into the Q data structure. Q is, again check the underflow condition. When the front and rear pointer is equals to equals, then right here Q is underflow, then return the 0 values. Otherwise we can delete the element. For set Q of front pointer is equals to elements, then increment that front pointer by 1, f is equals, that front is equals to front plus n, reset the front pointers and rear pointers, that front and rear point is equals to -1, and then stop. Now we can move to just give the answers of these questions. Just insert 10, 20, 30 elements into the Q data structures. We just observe, first we insert the 10, then 20 and then the 30. Now my question is, which element will be deleted first? Think and give me the answers. Now which element will be deleted first? Now if we are inserting the first element as a 10, of course the 10 element will be deleted first. These are the applications of the Q data structures, that is priority queue, machine shop simulation, image component labeling, wire routing, railroad path rearrangements. Now thank you so much.